Okay, so in today's notes, we are going to be solving equations using logarithms. So if we look at the equations on this page, they're all exponential. From our exponential functions unit, we solved exponential equations. The reason why we have to solve these exponential equations, okay, is because the bases or the numbers can't be written in the same base. So for instance, like 4 and 15, we can't write 15 as a base of 4. Now, 4 can also be written as a base of 2, but we cannot write 15 as a base of 2. Okay, so we have to solve using logs. So the first step that you want to do is isolate the exponential. Okay, so let's call that step 1. Okay, step 2. Okay, once we do that, so in question number 1, the exponential part is isolated. Then we take the log of both sides. And 3, we're going to solve for x. Now the answers have to be in exact form, okay? So that just means in terms of your log or natural log. So let's start with number 1. So we've isolated the exponential, or it's already isolated, so we're going to take the log of both sides. So it's the log of 4 to the x equals the log of 15. Now remember, the log of 15 is a number. Okay, if I go to the calculator, log of 15, okay, it's a number. Now when it comes to 4 to the x, we know what the x is, so we can't do the log of 4 to whatever that is. So we rewrite it using the power rule. Again, this x gets moved out front, so it becomes x times the log of 4 equals the log of 15. And now we can divide both sides by the log of 4 to get rid of the log of 4, because anything divided by itself is 1, and we're left with just x. So our final answer is going to be x equals the log of 15 over the log of 4. And if we wanted our answers rounded, we could, of course, type that into the calculator and round to the nearest tenth, hundredths, so on and so forth. All right, so number 2, the exponential is isolated. So we're going to slide that power out to the front. Oh, but first we have to take logs. So you can do it all in one step, so I shouldn't get ahead of myself. Let's write it in terms of a log first. So log 9 to the x plus 2 equals log of 15. Sliding that x plus 2 out front. So if you're pretty good, I'm just going to put that in parentheses. If you're pretty good in knowing that you need to slide that out front and then your log of 9, you can go ahead and skip this step. But because it's our notes, let's write it all out. All right. So now I need to isolate the x or solve for x, but because it's in parentheses, we're going to divide by the log of 9 first. And we get x plus 2 equals the log of 15 over the log of 9. So to finish, to get x by itself, we just subtract 2 from both sides. So our answer is x equals this fraction of log of 15 over log of 9 minus 2. Okay. The next question here, we do have to isolate this exponential, so we're going to subtract the 3. It'll be 2 to the x minus 6. 14 minus 3 is 11. So let's take the log of both sides. So log of 2 to the x minus 6 equals log of 11. We want to use our power rule to move that up front. So we have x minus 6 equals the log of 11 over the log of 2. And we need to add the 6 over. So x equals this fraction, so log of 11 over log of 2. And since that's minus 6 again, our answer will have plus 6. All right, let's actually do 5 first, and we'll finish with 4. So in this question here, because of e, and remember e is some number, we go to the calculator, that number is exactly 2.718 dot, 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 okay? Because of the e, we have to take the ln of both sides. So ln of 2 to the x equals the ln of e. We've got that power rule, slide it out front, so it becomes x ln of 2 equals the ln of e. Now, I should have actually at this step, the ln of e, if you go to your calculator, because it's base e, the ln of e is 1, okay? So at this step, I am going to go back and erase or use whiteout. The natural log of e is equal to 1. So I'm going to divide both sides by the ln of 2. Cancels that out, and x is equal to 1 over ln of 2. So watch out for log of 10 is 1, ln of e is 10. Okay, and if this number was any power of 10, right, you could also reduce that. All right, we're going to finish with 4 and then look at a couple word problems. So number 4, again, different bases. So we can't set the exponents equal. We have to take the log of both sides. So it's the log of 2 to the x plus 1 equals log of 3 to the x minus 2. They both have that power, so we're going to slide the powers out front. So it becomes x plus 1 log of 2 equals x minus 2 log of 3. So remember, that's a number. So what we want to do at this case, it wouldn't benefit us to divide by log of 2 or divide by log of 3 with x on both sides. So when you have x on both sides, you want to actually distribute with the log. So it's going to be log of 2 times x, or x log of 2 plus log of 2 times 1 would just be log of 2. Distribute on this side, x log 3 minus 2 times log 3 would be 2 log 3. So don't multiply the 2 and 3 to get 6. Remember, because log 3 is a number, treat it like 3x. So 2 times log 3 is log 3. So then we have these like terms. We have an x log on this side, an x log on that side, and then those terms without the x. So we want them on the same side of the equal sign. So I'm going to first move this to the other side. So it becomes x log 2 minus this x log 3. Because when you move it to the other side, it becomes the opposite sign. And then I'm going to slide this to the right side. Okay, so I have this negative 2 log 3 minus log 2. So I just am moving the like terms onto one side. Now, when x is a part of two terms, remember, we pull it out by the process of factoring. So it becomes x log 2 minus log 3 equals negative 2 log 3 minus log 2. And then we finish by dividing by this difference of log 2 and log 3. And x is by itself. Again, our answer is just left in log form. So x equals, and we're just going to copy down this fraction, which is just a process of steps. So if you need to copy that down, pause it. Otherwise, we're going to finish by looking at some word problems. Ooh, sorry about that. Just kicked the table. All right, applications. So the first one says, Bob invested $1,000 in a bank that earns 3% compounded annually. So that means we're going to use that compound interest equation from the exponential functions unit. So A equals P times 1 plus, it was R over N to the NT. How many years to the nearest tenth will it take for his investment to double? Well, his investment is $1,000. So if I want that to double, that would be 2 times 1,000. So I want my final answer to be that. We want to know how long is it going to take. So that's the T. Okay. If it's compounded annually, so our principal was 1,000, and then 1 plus the rate of 3% is 0.03, and annually would be over 1 to the 1 times t. So let's do some simplifying. So this would be 2,000. 1 plus 0.03 over 1 is just 1.03. Okay. So now we're going to take the log of both sides. But what I'm also noticing to solve, right, is this here can be reduced, or I can divide out that 1,000. So it's 1,000 times that to the t. So it's actually 2 equals 1.03 to the t. Okay, we have to isolate the exponential. Okay, so I had to get this part by itself. Now that it's by itself, we can take the log of both sides. So this is the log of 2 equals the log of 1.03 to the t. So I'm going to move it up here because we don't have much space. We have to slide this power out to the front. Okay, so it becomes log of 2 equals t log of 1.03. So in this case, we want to know how many years to the nearest tenth of a year. We're going to be entering our log fraction. So from the previous page, we're not going to leave our answer like this. We'll actually find the number and round. So divide by log of 1.03. And let's go to the calculator. Again, you want to use that fraction bar. So it's log of 2 and then log of 1.03.